So this is problem 2.18 out of Griffiths Electrodynamics. Before I get into solving this problem, I just wanted to ask if you wouldn't mind please liking this video and subscribing to my YouTube channel. It's a great free way to support me, and I post a lot of solutions from undergraduate physics textbooks. So if you're studying physics or interested in physics, I think you have a lot to gain from my channel. So let's get started. The problem says two spheres, each of radius r, and carrying a uniform volume charge density plus rho and minus rho, are placed so that they're partially overlapped. And this is figure 2.28, so you can see it. Call the vector from the positive center to the negative center d, so that the field in this region of the overlapped region is constant, and find its value. Hint: use the answer from problem 2.12. Problem 2.12 is another problem worked out in this channel, so if you're not sure about this result, you can check out that video. But the result is that our electric field E is equal to r rho divided by 3 epsilon naught in the r hat direction. Now in this overlapped region, that's kind of hard to see. Maybe that's a little bit better. So in this overlapped region, hopefully you can see that the electric field there, which I'll call E sub t, E total, is the electric field from the sphere carrying the positive charge density plus the electric field from the sphere carrying the negative charge density. So we're just adding up the two electric fields there to find their total, which, using the equation above, is r plus. So this is the positive, so it's just going to be positive rho over 3 epsilon naught r hat, and then minus r minus rho over 3 epsilon naught r hat, because your rho here is negative. So that's why there's a minus sign here. So this simplifies pretty nicely. We can factor out a rho. We can factor out a 3 epsilon naught. And we're left with the difference of these two vectors. Now, if positive r hat is the distance from the positive center to some point in this overlapped region, and r minus is the distance from the negative center to the same point in interest that we're interested in, then if we were to flip the r minus, so this is r plus, and now this is r minus because of the negative sign here. Well, this vector is now just the vector from the positive origin, or the origin of the positive sphere, to the center of the negative sphere. So then this term is just vector d. So then the electric field in this region is rho d over 3 epsilon naught r hat. So clearly that is a constant. The rho is not changing, d is not changing, and then epsilon is a constant. And this is the value for it. So pretty straightforward problem. Hopefully that makes sense, and if it did, please like the video and subscribe. Thank you.